Hey everyone, so today we're going to be taking a deep dive into the world of minerals and resource extraction. It's something that we all kind of interact with every day, but maybe don't think about too much. And you've sent us some fascinating slides on this topic, so hopefully we can unearth some of the intrigue surrounding geology and how it impacts, pretty much everything.
Yeah, you've definitely piqued my interest
What's
with
that?
this collection of slides. It's really quite fascinating to see, your interest span from the real basic, what is a mineral, all the way to like the environmental effects of mining. It seems like you're really thinking about this, the big picture, which is great to see.
Definitely. And this presentation you sent titled Minerals and Resources, I think this is like the perfect place to start, right?
Yeah, absolutely.
So before we get too in the weeds, I think maybe we should define mineral. Like when we say the word mineral, what are we actually talking about?
Yeah, no, that's a great place to start. And in your slides here, you highlight the four key characteristics that really define a mineral. So, to be a mineral, it has to be naturally occurring, inorganic, solid, and it also has to have a defined chemical composition and crystal structure. So it has to tick all those
So
boxes.
that like stunning quartz cluster that I keep seeing, all over the internet, that's a mineral, right? Like that's formed naturally over time. It's not something that we, synthesize in a lab.
Exactly, exactly. And that defined crystal structure that you're talking about is what gives minerals these really unique shapes. They have this almost like architectural beauty to them. It's really nature's way of organizing, atoms. But it's, more than just aesthetics. These structures also determine a mineral's properties, and this dictates how it behaves, what it can be used for, all of that.
Okay, so then it gets interesting because in slide 3, you introduce the terms ore and gangue minerals. It sounds like something straight out of like, Lord of the Rings or something.
It does. It does.
But yeah, so what are those?
Yeah, so it sounds very fantasy-like, but those are actually, it really all comes down to economics, right?
Right.
So when we talk about mining, you're digging up a rock, it might have a sparkle here, there, whatever, but what we're really interested in is the concentration of valuable minerals. So ore is basically just rock that contains enough of these valuable minerals to make it worth extracting. So that's where the economics comes in. It has to be profitable to get it out of the ground. And then gangue minerals, those are basically the less valuable minerals that are found alongside the valuable ore. So that's kind of, the stuff that gets left behind.
So it's not just about finding like a couple shiny rocks. It's about finding enough to make it worthwhile, I guess.
Exactly, exactly. You've got to find the mother lode.
Yeah.
And not only that, the type of ore that you're looking for, that's important too. And your slides mention a few common ones like oxides, sulfides, and silicates. So like hematite, that's an oxide ore, and that's what we use for iron. And then you have things like galena, which is a sulfide, and that's used for lead. And then bauxite, which is a silicate, that's what we use for aluminum. So these are really like the fundamental building blocks for countless industries.
It's amazing how all this raw material that we take for granted like underpins so much of like the modern world,
It really does.
But how do we actually like extract these valuable metals from the ore?
Yeah.
Like it's not like we could just, pluck them out.
Yeah, no, it's definitely more involved than that. And slide 5 talks about this process of smelting, which is essentially where you heat ore to really, really high temperatures. We're talking incredibly high temperatures, and this is using what we call reducing agents. So think like coke or charcoal. And what this does is it basically forces the metal out of the ore.
So we're not baking a cake here. We're like baking rocks at like, inferno like temperatures.
That's a great way to put it. Yeah, it's intense heat, and it helps to break down the ore and separate the valuable metals from the what we call slag, which is basically the waste material. But even after all of that, even after this intense heat, the metal that you get out is often still impure, so it requires further refining.
And that's probably where a lot of the environmental impact comes in, right? Like
Yeah.
I imagine that kind of intense process can't be, completely benign.
Yeah, you're absolutely right. I mean, mining and refining metals, it takes a lot of energy, and inevitably you're going to have some waste. So it's definitely something to think about. And we'll definitely get into that a bit later. But first, I kind of want to switch gears for a second and talk about two metals that I think have captivated humans for, centuries: gold and silver.
Yeah. And you've got slides 6 and 7.
Yeah.
Really diving into, their properties, their uses. And it's clear that these metals are, way more than just like shiny objects.
Yeah, that's what makes them so fascinating, right? Like, take gold, for example. It's incredibly malleable, which means you can shape it really easily,
Yep.
and it's incredibly resistant to corrosion. So those two things together make it just perfect for electronics, right? Especially like the tiny, tiny intricate circuits in our phones, computers, things like that. You need something that's not gonna, tarnish and fall apart. And of course, the use in dentistry is a testament to its longevity, right?
Yeah. What about silver? I know it's not all, silverware and jewelry these days. What else is silver used for?
Oh, silver is a workhorse. One of its most amazing properties is its conductivity. It's actually the most conductive metal on Earth. So if you think about anything involving electricity, silver's probably in there somewhere, making sure those electrons are flowing the way they're supposed to. So, from your smartphone to solar panels, silver is kind of, behind the scenes making it all happen.
Wow. It's crazy to think that these metals often associated with, luxury and kind of this ornamentation are like, quietly powering so much of our modern lives.
Ah,
But it seems like nature has kind of lent us a hand in concentrating these valuable resources, right? You mentioned placer deposits on slide 8. What are those exactly?
So imagine a river, right? It's flowing over rocks for, millennia. And certain minerals, particularly ones that are resistant to weathering, things like gold, they also tend to be very, very dense. So over time, as that river flows and flows, those dense minerals settle and they concentrate in the riverbeds. And we call those concentrations placer deposits. And these are actually what have been the source of, countless gold rushes throughout history.
Oh, okay. So that's like the classic image of, prospectors panning for gold. It's a
Exactly.
classic for a reason.
Exactly. It perfectly illustrates how, geological processes acting over these vast, vast stretches of time can actually concentrate these really valuable resources and, kind of make them accessible to us. But of course, not all, essential resources are, glittering metals found in riverbeds, right?
Slide 9 here takes us to a different kind of resource, fossil fuels. And these are formed over millions of years from the decomposition of ancient life. Right, so fossil fuels,
Hmm.
coal, oil, natural gas, they're everywhere, right?
right.
Powering our cars, heating our homes. It's kind of amazing that I don't really know how they form. Like,
Yeah.
what is that process?
It is fascinating. And understanding their origins is really crucial to understanding, I think, a lot of the challenges that we're facing today. But basically, fossil fuels formed over millions of years from the decomposition of organic matter. So think, ancient plants and animals primarily. And this is all happening under immense heat and pressure. So it's kind of like these pockets of, ancient sunshine that are trapped beneath the Earth's surface.
And so that's why they're non-renewable, right?
Yeah.
Because we're using them up way, way faster than they could ever be, replenished.
Exactly.
And I guess that highlights why there's such a push for, alternative energy sources these days, right? It's not just about finding, substitutes. It's about moving away from something that is ultimately finite. We're going to run out.
Precisely. And
Yeah.
and we can't forget about the environmental impact of actually burning these fossil fuels, right? Because when we do that, when we burn them, we release carbon dioxide, which is a major greenhouse gas, into the atmosphere, and that contributes to climate change, right? So it all kind of ties back to this idea of, we need to think about the full life cycle impact of these resources that we depend on. So from extraction and processing to use, and then eventually disposal as well, it all plays a role.
And then that kind of leads us to, I think, maybe some of the more challenging aspects of resource extraction, right? The environmental consequences. You've got slides here on both subsurface and surface mining, and some of these images, I got to say, are pretty stark.
Yeah, they can be. Slides 10 and 11, I think, do a really good job of kind of visually comparing these two methods. So you have subsurface mining, which, as the name implies, you're tunneling underground to get to these deeper deposits. So think about, the classic images of mine shafts and carts coming out laden with ore. And while this might seem less intrusive, at least on the surface, subsurface mining has its own challenges, right?
Mhm.
Especially when it comes to things like worker safety. And then there's also the potential for groundwater contamination, things like that.
And then on the other end of the spectrum, you have surface mining, which is like the opposite approach, it seems like.
Yeah, exactly. And this is often used for shallower deposits. And
Mhm.
basically it involves removing the overlying soil and rock, what we call the overburden, to get to that valuable ore underneath.
Okay, so that's what I'm picturing, like those massive, like, terraced open pit mines, those, like, scars on the landscape that you can see from space.
Yeah. You got it. That's often what you see with a type of surface mining called strip mining, and you're right. It creates these dramatic landscapes, and it tends to be more cost effective than subsurface mining. However, as you can imagine, it can drastically alter, landscapes and disrupt ecosystems.
So it really does seem like there's this delicate balance, right,
Mhm.
between like we need these resources, but then the process of getting them can have some pretty serious consequences.
Absolutely. It's complex. There's no easy answers. But that doesn't mean that it's, a hopeless situation at all.
Okay, that's good to hear. So what about land reclamation? You have I think it's slide 12. It talks about efforts to restore, land that's been mined. Like, is it even possible to heal those landscapes after, such intensive extraction?
It is possible. It's a long process, it's complex, and it often requires, decades of effort and really ongoing monitoring to make sure that it's successful. But the goal is basically to try to return that land to, a stable and productive state. And that can involve a lot of different things. Removing any kind of mining structures that were there, managing the waste, neutralizing any kind of hazardous materials, and then, replacing the topsoil. It can even involve recontouring the land itself to kind of mimic its original shape. So it's a big job.
Yeah, it sounds like, trying to piece back together something that's been, fragmented. It's got to be tough.
It is, and it really highlights, I think, the long-term responsibility that's associated with resource extraction, right?
Yeah.
We can't just take what we need and walk away. It's about minimizing the impact during extraction, but then also actively working to restore that land afterwards. And it might be costly, but
Mhm.
it's crucial for minimizing that long-term environmental impact.
That makes a lot of sense. I noticed you also included like some thought-provoking discussion prompts in these slides. For example, slide 13 asks, what are some valuable minerals mined in your region?
Oh, that's a good one. I like that one.
Yeah.
Because it reminds us that this isn't just some, theoretical discussion. This is happening all around us, right? Every
Yeah.
region has its own unique geological history, and that dictates what kind of mineral resources can be found there. So it's an invitation to kind of connect this global issue to our own backyards, right? What's happening where we live.
Yeah, it really hits home when you start to think about like where are the materials for like everyday objects. Where does it all come from, right? This phone in my hand. It's not just a phone. It's like it represents this whole global network of resource extraction, manufacturing, transportation, like all these crazy complex processes that we just totally take for granted.
It really highlights how interconnected our world truly is, both in terms of the resources that we depend on, but then also, the environmental challenges that we share, right?
Yeah.
It's easy to kind of forget that each action we take, even something as simple as, buying a phone, has these ripple effects that extend, way beyond ourselves.
It makes these deep dives all the more important, right?
Yeah.
Like the more informed we are as individuals, the better equipped we are to actually like make responsible choices.
100%. Understanding where our resources come from, what's the impact of extracting them, using them. It's essential. Knowledge isn't just, they say knowledge is power, but it's also a responsibility.
Yeah, that's a good way to put it. And speaking of responsibility, that second discussion prompt you have on slide 13, that's a powerful one. How can we balance the need for mineral resources with environmental protection? That feels like the million-dollar question.
It is. It's really the crux of the whole issue, right? And I don't think we can't just, wish away our need for these resources, but we also can't just, continue with practices that we know are not sustainable, right? So it requires us to kind of, I think critically about our own consumption patterns, embrace new technologies, innovative technologies, and then also just accept that, there are trade-offs, right? There are always going to be trade-offs inherent in any kind of, resource extraction.
It can feel kind of overwhelming, I think, sometimes.
Mhm.
But I have to believe that there are, paths forward, ways to kind of make our resource use more sustainable.
There are. And I think, it's about finding ways to minimize our impact, throughout that entire life cycle of a resource, right? So from extraction and processing to use and then crucially end of life management as well. It takes collaboration too, right? Governments, industries, consumers, everybody's got to play a role.
And that's where that final discussion prompt on this slide, I think, comes in, right? It
Yeah.
says, what are the benefits and drawbacks of different mining techniques? So it's like, it's like weighing the pros and cons, right? Thinking about the environmental costs, the social costs, and really just pushing for, continuous improvement.
Yeah, absolutely. We have to be willing to ask those tough questions, right? Like,
Yeah.
how can we make existing mining techniques more efficient, less damaging? Can we come up with entirely new approaches to resource extraction that really minimize, that environmental impact? And then maybe even, looking even further down the line, can we explore, alternative sources altogether, even, potentially beyond Earth itself?
Which brings us to that final, that almost kind of like, science fiction provocation that you included here, asteroid mining.
Right.
It sounds like something straight out of like, a movie, but I, I think it also just highlights how crucial this conversation is becoming.
It really does, and it's a testament, I think, to human ingenuity, our desire to kind of push those boundaries of what's possible. Because as our demand for these resources continues to grow, we're going to have to, explore every avenue, right? From improving how we manage, Earth's finite resources to potentially, going out and harnessing resources from space. But I think the key in all of this is to proceed thoughtfully, right? Weigh those potential benefits against the risks, and always make sure that ethical considerations are front and center.
It's a lot to think about, but that's what makes these deep dives so fascinating, right? You've given us this crash course in minerals and resource extraction, but even more importantly, I think you've left us with this deeper understanding of just how complex this issue is, and really just the importance of informed decision making.
It's my pleasure. Like you said, it's not about having all the answers. It's about asking the right questions. And it sounds like, from the sources that you shared with me, you're already doing that. You're asking those questions. You're thinking about it, and that's what matters.
No, I appreciate that. And to our listeners, here's a final thought to kind of ponder. We've talked about how even something is seemingly simple as the objects around us, they rely on this vast and often hidden network of resource extraction and manufacturing. So knowing that, what changes, if any, are you willing to make in your own life and your own consumption habits to really kind of support more responsible and sustainable practices? It's something to think about as we continue to kind of navigate this increasingly complex world. So until next time, keep those minds engaged.